स्मार्ट माइंड्स ट्यूटोरियल सफलता का आपका प्रवेश द्वार।
So find the eigenvalues of a matrix A is equal to 401 minus 210 minus 201. So first let us write the given matrix. What is the given matrix? Given matrix is A is equal to 4, 0, 1 minus 2, 1, 0 minus 2, 0, 1. Now we need to find the characteristic equation. What is the formula for characteristic equation? It is given by determinant A minus lambda I is equal to 0. So what is A? A is 401 minus 210 minus 201 minus lambda I means lambda 0 0 0 lambda 0 0 0 lambda. What did I do over here? I multiplied lambda with identity matrix. What is identity matrix? 1 0 0 0 1 0 0 0 1. So we got this. Now we need to find determinant of this is equal to 0. Now let us subtract these two matrices. So you will get 4 minus lambda 0 1 minus 2 1 minus lambda 0 minus 2 0 1 minus lambda is equal to 0. Now you expand the determinant. So first you take the first element 4 minus lambda. Now you cross multiply this. So you will get 1 minus lambda whole square. Now 0 into anything is 0. So we are not doing with 0. Then again we are doing with the third element plus 1 into. Now you cross multiply this. So 0 plus 2 into 1 minus lambda. How do we find the determinant? This 1 into this you cross multiply minus this you cross multiply. Okay. So that is equal to 0. Now 4 minus lambda into 1 plus lambda square minus 2 lambda plus 2 minus 2 lambda is equal to 0. Now let us multiply these two brackets. 4 plus 4 lambda square minus 8 lambda. First I multiplied 4 with the whole second bracket. Then I will multiply minus lambda with the whole second bracket. So minus lambda cube plus 2 lambda square plus 2 minus 2 lambda is equal to 0. Okay. Now if you simplify this, what do you get? Minus lambda cube plus 6 lambda square minus 11 lambda plus 6 is 0. Always make sure that first term should be positive. So we take minus common. Lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. Now you have to factorize this. So first you put lambda is equal to 1 to check if this is satisfying or not. 1 minus 6 plus 11 minus 6 is 0. 1 plus 11 is 12. Minus 6 is minus 12 is 0. So 0 is equal to 0. Therefore, lambda is equal to 1 is a root. Lambda is equal to 1 is a root. Now you got one root, but we want remaining two roots also because it is a cubic equation. So we will do this by synthetic division. Now look at this step. I am just taking the coefficients. So 1 minus 6, 11 minus 6. Now 1 is a root, right? So I am writing 1 over here. Always take the first number as 0. Now add this. 1 plus 0 is 1. 1 into 1 is 1. Minus 6 plus 1 is minus 5. Minus 5 into 1 is minus 5. 11 minus 5 is 6. 6 into 1 is 6. Minus 6 plus 6 is 0. Now this, how can I express as a quadratic equation? 1 into lambda square minus 5 lambda plus 6 is 0. Now you factorize this. Lambda square minus 3 lambda minus 2 lambda plus 6 is 0. Lambda common, lambda minus 3 minus 2 common, lambda minus 3. So lambda minus 3 into lambda minus 2 is equal to 0. So lambda is equal to 3 comma 2. Therefore, lambda is equal to 1, 2 and 3, which implies eigenvalues are 1, 2 and 3. So this is the way of finding eigenvalues. Got it? Take the next question. Prove that the eigenvalues of a triangular matrix are its diagonal elements. So this is a theorem kind of question. Okay, we need to prove that eigenvalues of a triangular matrix are its diagonal elements. So let A be a 3 by 3 matrix. 3 by 3 matrix means which has 3 rows and 3 columns. That is A is equal to A11, A12, A13, 0, A22, A23, 0, 0, A33. Be an upper triangular matrix. The characteristic equation of matrix A is determinant of A minus lambda I is equal to 0. That is determinant of what is A? A11, A12, A13, 0, A22, A23, 0, 0, A33. So what do you mean by upper triangular matrix? Below the principal diagonal elements, all are zeros. Minus lambda I is lambda 0, 0, 0 lambda 0, 0, 0 lambda is equal to 0. Now you subtract these two, what do you get? If you subtract, you will get determinant of A11 minus lambda, A12, A13, 0, A22 minus lambda, A23, 0, 0, A23 minus lambda is equal to 0. Now we need to expand the determinant. Let us expand along C1. So just you take this and you cross multiply this. You will get the answer. So A11 minus lambda, here let us write expanding the determinant along C1 into A22 minus lambda into A23 minus lambda minus 0 is equal to 0. So A11 minus lambda into A22 minus lambda into A23 minus lambda is 0. Each bracket, if you equate to 0, you will get lambda values as A11, A22, A23. Therefore, we got the eigenvalues. Eigenvalues are lambda 1 is equal to A11, lambda 2 is equal to A22. This is A33. This is 33, not 23, okay? 33. So lambda 3 is A33. Now you can conclude, hence the eigenvalues of an upper triangular matrix are the entries of its main diagonal. Okay, we have taken low upper triangular matrix, but in the question it is given only triangular matrix, means we have to find for both upper and lower. Now let us take for lower. So let lower means above the principal diagonal elements, all are zeros. Okay, so A11, 0, 0. This will also be 0. Then A21, A22, A31, A32, A33. Be a lower triangular matrix. So what is A transpose? A transpose is A1. Transpose means interchanging rows and columns. So the row you write in the form of a column. So automatically columns will be arranged in the form of rows. Now you can see the eigenvalues of A and A transpose are same. Hence, the eigenvalues of a lower triangular matrix are the entries on its main diagonal. Finally, I am concluding it over here. Therefore, the eigenvalues of a triangular matrix are the entries on its main diagonal. This is what we had to prove. Okay. Take the next question. This is also very important. Show that if V1, V2, so on up to Vr are eigenvectors, that corresponding to distinct eigenvalues lambda 1, lambda 2, so on up to lambda r of an n by n matrix A, then the set V1, V2, so on up to Vr is linearly independent. So let us say m be a positive integer such that V1, V2, so on up to Vm are linearly independent. Now, if m is less than r, then Vm plus 1 is a linear combination of V1 so on up to Vr. That is, Vm plus 1 is equal to C1V1 plus C2V2 plus so on up to CMVM. Now applying matrix A. What do you get? A into Vm plus 1 is equal to lambda m plus 1 Vm plus 1. That is equal to lambda m plus 1 into what is Vm plus 1? C1V1 plus C2V2 plus so on up to CMVM. Now that is equal to, now we multiply that lambda inside. So C1 lambda m plus 1 V1 plus C2 lambda m plus 1 V2 plus so on up to Cm lambda m plus 1 Vm. Also, A into Vm plus 1 is equal to A into C1V1 plus C2V2 plus so on up to CMVM. Now multiply this A inside. So C1A V1 plus C2A V2 plus so on up to CMA Vm. That is equal to Cm. What is A? A we can write lambda 1. Lambda 1 V1 plus C2 lambda 2 V2 plus so on up to Cm lambda m Vm. Therefore, C1 into lambda m plus 1 minus lambda 1 into V1 plus C2 into lambda m plus 1 minus lambda 2 into V2 plus so on up to Cm into lambda m plus 1 minus lambda m into Vm is equal to 0. Now, since V1, V2, V3, so on up to Vm are linearly independent, if they are linearly independent, how can we write? C1 into lambda m plus 1 minus lambda is equal to C2 into lambda m plus 1 minus lambda 2 is equal to so on. That is equal to Cm into lambda m plus 1 minus lambda m is equal to 0. Now, eigenvalues are distinct. Distinct means they are different. Eigenvalues are distinct. That is, C1 is equal to C2 is equal to so on up to that is equal to Cm and that is 0. That means Vm plus 1 is equal to 0. But this is contradictory, no? This is contradictory to which statement? To Vm plus 1 not equal to 0. Therefore, V1, V2, so on up to Vm are linearly independent.